formula for the integrating factor is very simple. P of x is just the exponential of the integral of P of x dx. Okay, so you put the equation in your standard form, you look for the coefficient of y, you integrate that and do e to that expression. That's the integrating factor. Okay? 3 multiply, let's call this star, equation star. So multiply star, and that's the important thing. Some people make a mistake, they multiply not this by the integrating factor, but the original one by the integrating factor. So you take your equation, remember if there's a coefficient over here, divide through, and now forget about that one. Only work with this one. So basically you take your standard form now, multiply that by phi of x. And you'll find out that the left-hand side will always be d by dx of the integrating factor times y. And then it'll be obvious what to do. Then you just integrate both sides, and you'll have the solution. Okay. So I think the best thing is just do some problems now. Okay. Any questions on the derivation? Again, this whole trick basically of integrating factor is to basically choose a function phi so that when you multiply the left-hand side by phi, it's d by dx of some expression. I know how to integrate d by dx of an expression. You just integrate it, right? Then it could be easier. You don't have to worry about doing integration by parts. It's d by dx of something. What's the integral of d by dx of something? It's just the something that you have, that you started with. Okay. We'll start off with some simple equation. Okay. And you can look at the book, and their derivation is okay, but I think it's much more complicated than necessary. You could be the judge of that. Okay, let's do example one here that I have. Let's start off with the differential equation, dy dx minus 3y is equal to 0. That's actually an autonomous equation, it's even separable, but we'll be able to do this. The general one that I had over here, that's not separable, right? Right? If p of x and f of x are given functions of x, that's not of the form dy dx is a function of x times a function of y. And we'll do ones like that very shortly. So let's start off with dy dx minus 3y equals 0, okay? Okay, if I look at the standard form over here, what's my p of x over here? I look for the coefficient of y, which is negative 3, right? Okay, so the integral of p dx is minus 3x, right? And therefore, the integrating factor, okay, is just e to the minus 3x. After a while, you'll just be able to do this in your head, right? You'll say, oh, there's the coefficient of y, I integrate, I get minus 3x, e to the minus 3x is the integrating factor. So let's take the equation, multiply both sides through by e to the minus 3x. E to the minus 3x dy dx minus 3 e to the minus 3x times y is equal to 0. And if I've done things right, you see the theory tells me that the left-hand side is what's called an exact derivative. Okay? Okay? What should happen is that the left-hand side should be d by dx of the integrating factor times y. And what I recommend that you do at this point, even though you know what the answer is, it's a good way to catch errors. Okay? Because suppose you made an error, this one's real simple, and somehow you integrated wrong and the integrating factor was wrong, then the left-hand side will not come out in general to be d by dx of the integrating factor times y. But just use the product rule on this before we go on. Is this expression here, the left-hand side, really this? Sure, use the product rule. You get e to the minus 3x dy dx plus y times the derivative of e to the minus 3x, which is minus 3 e to the minus 3x. So it does check. So that equals 0, right? The derivative of something is 0 has to be a constant, right? Integrating both sides, e to the minus 3x times y is an arbitrary constant. Call it c. So the solution is arbitrary constant e to the 3x. That's your general solution to the equation. And you would have gotten the same thing if you did, variable separable. Okay. Example number 2 will be very similar, but the right-hand side will be non-zero. Okay, example 2. And we can just save what we did from example number 1. That's going to be dy dx, same left-hand side, minus 3y, and let's put on the right-hand side 6. Okay? That was homogeneous, that's not homogeneous. Okay, now you notice that the stuff with the integrating factor only deals with the left-hand side, right? It has nothing to do with f of x. So we don't have to do all the work over again. Here's my p of x is -3. It's the same integrating factor as before, right? The integrating factor is independent of the right-hand side. So I multiply through by e to the minus 3x, okay? So I get e to the minus 3x dy dx minus 3 e to the minus 3x times y. But now I don't have 0, I have 6 e to the minus 3x. Right? Well, the argument I gave before in the last example certainly applies. Okay, the whole reason for choosing the integrating factor is so that I could write this as d by dx of the integrating factor times y. Okay, we check that, and indeed the left-hand side does check with the above. But now we have what? 6 e to the minus 3x. Okay? In the other case, in example number 1, I was integrating 0. But big deal. Now I integrate both sides with respect to x. Obviously, the left-hand side is still e to the minus 3x times y. And the right is the integral of 6 e to the minus 3x. Which I believe would be minus 2 e to the minus 3x plus the arbitrary constant. Right? So differentiate that, I get plus 6 e to the minus 3x. Now let's multiply through to solve for y. And you get minus 2 plus an arbitrary constant e to the 3x. Okay, so that's the solution to that one. And again, the beauty of this thing is that you can always check it, right? Okay? Go back with this expression for y, do dy dx minus 3y, and I guarantee that you'll get 6. Okay? Okay, now let's go to one which, in that one also is not variable separable, right? So we couldn't do it by the other technique. Okay, let me do example 3 over here. Okay, x dy dx, right? There's no way you could have done this one the first day of class, right? X dy dx minus 4y equals x to the 6 dx.
Professor?
Yes?
Where, in this one here,
Sure.
Where's the negative 2 come from?
Because just do the integral of e to the minus 3x,
Oh.
it's e to the minus 3x over negative 3.
Okay.
And 6 over negative 3 becomes
Yeah.
negative 2.
Okay.
Okay.
Are you missing the negative 3x or
No, I don't believe so. Where?
on the y equals negative 2 plus c1?
No, I did is I multiplied both sides by e to the 3x.
You see 1 over
So that one
negative.
annihilated. E to the 3x times e to the minus 3x
Okay, gotcha.
is 1. Okay. So next equation, x dy dx minus 4y is x to the 6th e to the x. Okay. Oh, let me just stop at this point. That's just at the beginning of class. More people here today. Okay. I got several inquiries on the homework saying that, oh, you assigned problem number 41, and 41 that you have on the Moodle page and what I have in my book are different. I thought I said, correct me if I'm wrong, the first day, yes, that's going to happen because you have different editions of the book, and that's why I put it in Moodle. Okay? So just remind you again, always look at the problem that's posted on the Moodle page. Okay? Because that's from edition 9, I think, of the book. Okay?
So that's why-
And hence, like I said, if you use edition 10 or some other edition, it may not match up.
It didn't.
Another thing was things about the, everyone's, I guess, what, people are giving midterms now, so people asking me, and I sent out an email about that. Okay? So, right? Everybody got that?
Yep.
Okay. And again, as soon as I can figure, it's hard for me to tell because I don't want to rush things just to make an artificial date. Okay, we're pretty safe as far. We got some, margin, so to speak. So let's just get the material done, make sure we have it thorough, and then we'll talk about the test. Okay, so x dy dx minus 4y, xy prime minus 4y equals x to the 6th e to the x. They want to be able to solve that equation. Okay, remember what I said, gotta put it in the standard form, right? And the mistake that people would make at this point is they'd say, oh, P of X is -4, that's the Y coefficient. No, but this basically started, the starting point was 1 dy dx. Why? Allergies. Okay, let's divide through it to get the standard form. You get dy dx minus 4 over xy equals x to the 5th e to the x. Right? I divide through by x. Okay. So now this is my p of x over here, right? P of x is equal to that, right? We could do that one. Let's just do it slowly. What's the integral of p of x dx? Okay, it's -4 times the log of x. Right? And yeah, here's what you have to know your laws of logarithms, okay? Which is, I'm going to exponentiate this thing, right? So I basically want to write this as the logarithm of x to the -4 power. Okay? Remember your rules of logs, right? Log of x to a power is the power times log x. Now why do I want to do that? Because I'm going to do the integrating factor, which is the exponential of this guy. I'm going to do the exponential of the log of x to the -4. Well, that's easy, right? Because by definition, log of x to the -4 is what power do I have to raise e to get x to the -4. And then I'm exponentiating that, they're inverses of one another, so it's x to the -4. So apparently the integrating factor is x to the -4. And again, remember I said, once you do this, forget about it. This is the equation we're dealing with. Don't multiply this guy by x to the -4 because our derivation said you start with the standard form, and this is the formula for the integrating factor. So let's take this equation over here now and multiply through by the integrating factor, which we found to be x to the -4. Well, then you get x to the -4 dy dx. Okay, be careful. -4, I guess that's x to the -3 now. What, no?
X to the -5.
-5. Oh, no, x to the -4. -4 x to the -5 times y equals, be careful now, integrating factor is x to the -4, so it's x e to the x. Okay? See, this is a good way, like I said, if I had made that mistake with the power, I would get it on the next step. We know that if we haven't made an algebraic error, at the left-hand side, these two terms, basically are going to be d by dx of the integrating factor times y. So let's just write that down. D by dx of the integrating factor, which was what? X to the -4 times y. Okay, stop. Use the product rule to check yourself. Expand that derivative. What do I get by the product rule? I get x to the -4 dy dx plus y times the derivative of x to the -4, which is -4x to the -5. See? So it's fine. And this is where you catch a lot of errors sometimes. So you've screwed up the integration or whatever, then when you do this thing where you know it has to be integrating factor times y, and you differentiate, it doesn't match, you made an error, so go back. Okay? So that equals x e to the x. Okay, now let's integrate both sides. We get x to the -4 times y, right? Has to be the integral of x e to the x dx plus an arbitrary constant. Okay? Now I don't expect you to remember the integral of x e to the x, but let's just do it by parts. Okay? What's the integral of x e to the x dx? I'll integrate by parts. That'll be my u and that'll be my dv. So du is dx, v is just e to the x, right? So integrated by parts, you can give these uv, which is going to be x times e to the x minus the integral of that dx. Okay, which equals x e to the x minus e to the x, or e to the x, x minus 1. That's that integral that I want. Okay, let's check it out. Let's differentiate that. I get e to the x times 1. Check that out. Let me just differentiate that. I'll get e to the x times x minus 1 plus e to the x. Yeah, x e to the x. Okay. So continuing on, basically, okay, we now have the right-hand side, that integral that we had to do. And again, just as a way of a comment, is that, like I said, I expect you to know basic integrals of sines and cosines, the exponential, things like integration by parts. If you were on the exam, let's say, to some weird integral, like, you know, arctangent, something like that, you probably made an error, okay? I'm not going to give you some crazy integral to do and waste your time. So the best thing to do with this strategy is to say, okay, I may take an integration and just kind of explain what you would do after that. We'll talk about more of that later on. Okay, so where are we? So we have x to the minus 4 times y on the left-hand side. The integral of x e to the x we just did. It's e to the x, x minus 1. Right? Plus an arbitrary constant. See? Okay, you always, and what happens, you know, when on an exam or just even in practice, when it says solve the differential equation, okay, you always desire to get y as a function of x, or the dependent variable is a function of independent variable, whatever they may be, okay? So you would lose credit kind of if you stopped at this point. Sometimes, as we saw, we get implicit relations, and there's no way that we can solve for y in terms of x. But here we easily can, right? So y equals what? You get x to the 4, x minus 1, e to the x, plus c x to the 4. Let's just check if that's right. X to the 4th, e to the x, x minus 1, plus arbitrary constant, x to the 4th. That's correct. Okay? See, so the technique is always the same. You put the equation in the standard form, you identify the coefficient of y in the standard equation, integrate that, exponentiate, that's your integrating factor. And the left-hand side will always be, if you haven't made a mistake, d by dx of the integrating factor times 1.